Each element in the PCB Editor database has a unique database identifier that allows you to refer to that object, and each element type has a specific set of member attributes. For example, we've already obtained 2 via DB IDs, and stored them in the variables via 1 and via 2, and we have obtained 2 connect line segment DB IDs, and stored them in the variables C line seg1, and C line seg2. These DB IDs are really pointers to skilled data structures that are created dynamically as they are needed. Every data type has a well-defined set of members or information that you can request about that object type, and the -- operator will return that list of members. For example, via 1 returns a list of all the members of all via DB IDs, and C line seg1 returns a list of all the members of all connect line segment DB IDs. Notice that C line seg2 will return the same list of members as line seg1 Every connect line segment in the PCB Editor database shares the same set of members. To find the value of a member attribute of a DB ID, you use the member attribute operator, the -- followed by the name of the member attribute. For example, C line seg1 returns the width of the connect line segment stored in the variable C line seg1, and C line seg2 returns the width of the connect line segment stored in the variable C line seg2. Notice that C line seg1 net returns a DB ID, the DB ID of the net that C line seg1 belongs to. If we store the net DB ID in the variable net1, the net1 will return a list of the member attributes for all net DB IDs. One of the attributes of a net DB ID is name, so net1 name will return a string, the name of the net that the net DB ID represents. The member attribute operator can be chained together, so C line seg1 net name will return a string with the net name of the connect line segment C line seg1 belongs to. Every DB ID type has the read-only attribute, and it always returns a T, to indicate that the attributes of the DB ID are read-only. They cannot be assigned a new value directly in skill. This means that we cannot simply assign a new value to the attribute of a DB ID with the assignment operator, to change the object. For example, if we first look at the endpoints of C line seg1 using the start-end attribute, we see its current location. Because DB IDs are all read-only, we cannot simply say C line seg1 start-end equals list 00, 100 0, to assign new endpoints to the C line segment. Although no error is thrown, notice that the start-end of our C line segment did not change. To make changes to the PCB Editor database, you must use the Axle API functions for modifying the database, such as the Axle transform function, or the Axle delete object function to delete objects, and then use the Axle create set of functions to create new elements in the database. Let's find the drill size of the VIA stored in the VIA1 variable. Since it is nearly impossible to remember all the attributes associated with all the object types, it is often convenient while developing your skill applications, to use the skill interpreter to investigate the different object types and their members. VIA1 shows the different members of the VIA, and VIA1 obj type indicates that the object type is a VIA. If we look at the other members, we don't see any that look like they would return the drill size of the VIA. However, we must remember that VIAs are an instance of a padstack definition. Then notice that VIA1 definition returns a DB ID, and the object type returned by VIA1 definition obj type is padstack. Padstacks are the padstack definitions, and VIA or pin is then an instance that uses that particular padstack definition. Let's store the padstack definition in paddef, with paddef equals VIA1 definition, and then paddef will return a list of the attribute members for padstack definitions. Notice the drill diameter is one of the attributes of a padstack definition. This means that via 1 greater than definition greater than drill diameter will return the drill diameter of the via stored in the variable via1. There are dozens of object types in the PCB Editor database, and hundreds of attribute members across them, so showing them in a video is impractical. They are all documented in the Allegro Skill Reference Manual, which you can access by selecting Help, Documentation, from the PCB Editor text menu, to open the Cadence Help application. From the Cadence Help application, click the Show Library icon and expand the Allegro PCB Editor Manual. Expand the Allegro User Guide and then expand the Allegro Skill Reference Manual. Expand the Allegro PCB Editor Database User Model Manual, and the chapter you are interested in is the description of database objects. Here each database object type is documented along with all the attribute members for that object type. In summary, each element in the PCB Editor database has a unique database identifier that allows you to refer to that object, and each element type has a specific set of member attributes.